Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. In an ideal world, everything we use would be reused or recycled. Currently, only around 10% of plastics are recycled, and one reason for this is that current recycling approaches can lead to a product with variable properties, something that is unfavourable for the plastics industry. In contrast, nature is pretty good at working with variability. Seashells are tough, with an organised microstructure giving rise to this toughness. One research group has harnessed this approach to produce a proof of concept recycled high-density polyethylene with a high recycled content. The structure is similar to bricks and mortar. The bricks, measuring a few centimetres across, are made from recycled plastic and held together by virgin material, leading to a recycled content of 70%. Importantly, the stiffness variability was reduced by around 90% compared to using only recycled plastic, a property that is important for the packaging industry. Maximum permissible strain was also reduced by almost 70%. The approach is unusual and demonstrates what can be achieved by tackling the problem by looking at it from a mechanical perspective, rather than the usual method of starting with a pure feedstock. Assistant Professor Christos Athanasiou from the Georgia Institute of Technology explains.
This whole paper and the study in general is very unique because of this creative approach. Nobody ever thought of using mechanics of materials thinking to solve this problem. That's a problem that typically chemists and maybe material scientists try to address, but this is kind of like a unique way of seeing the problem. The fact that we were the first one to approach a recycling problem from a mechanics of materials perspective is what really got me excited. And the fact that a simple composite architecture could go so far into answering such an important question.
The work began with computational modelling, where deformation is dictated by the tension in shear interfaces. Using literature data, Monte Carlo simulations were then used to scan parameter space and predict the variability of a given structure. The model was then validated experimentally. Following on from this proof of concept, the study, which involved grad student Dimitros Georgiou and postdoc Dancy Sun as lead authors, can expand to look at producing the virgin material from sustainable sources, scaling up, and even how the recycling method could be used in future space exploration missions where resources will be limited.
We are working on creating the soft part, the adhesive, what we call the glue, using bio-based materials so that the whole structure can be more environmentally friendly. This is one direction, and the other direction is there's a lot of recycling related questions that are very interesting for space exploration. People in space have very limited resources. So there's a lot of talk about recycling plastics and the resources that we find basically in space environments so that we can make best use of them, especially in long missions that can last years. So that's another direction that we're currently exploring. This is a benchmark study that tells us that with clever thinking, we could make better use of our materials in space. And the third thing is that we're thinking of is how to scale this approach up and how to find a good manufacturing method in a way that makes sense from a cost perspective.
The research could hopefully improve recycling rates and contribute to a circular economy where recycled plastic, despite being made from a heterogeneous feedstock, still retains excellent mechanical properties with low variability. This work was published in a recent issue of the Proceedings of the National Academy of Sciences. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.